Hello and welcome. We'll just start with that the remaining properties that we have just left alone. I'm starting with the density. Density, we define it as rho. So all of us know that density is simply mass upon volume of soil. It is in kg per meter cube. So this is simply mass upon volume. So we just define that in a particular volume of 1 meter by 1 meter by 1 meter. If you consider steel and if you consider wood and you are trying to compare these materials, then if you consider this much amount of steel and if you consider this much amount of wood, then it may happen that this much amount of wood will weight more and this will weight less. So for comparison purpose, we consider equal amount of material and that equal amount is unit volume. So for unit volume of any material, what is its mass? This is termed as density simply. So we define the denseness or sparseness on the basis of density. Next we have got Newton's second law. I would not define that rate of change of momentum etc. concept. I would just go what is important. Mass into acceleration. So for force, for earth we can define that whenever any downward force is acting for any body with some mass, so its mass acts in downward direction due to some acceleration to gravity. As you know that 1 Newton force is defined as 1 kg of mass accelerated by 1 meter per second square. This is defined as simply 1 Newton. So for earth we have gotten gravitational acceleration of this meter per second square. So for this I have got force. This force in downward direction for any body we can define as weight. This is simply mass and this is acceleration to gravity g. If you divide total volume of soil mass on both sides, we'll get this term and we'll get this term. So this term is simply rho and this term is called as specific weight, that is simply gamma. It is called as specific weight or unit weight. This is simply termed as gamma. So we deal in gamma. Because it is constant for earth and means generally we deal in case of gamma. So if these gamma for any soil we can define as simply gamma soil. You can define its moist unit weight. I mean the weight simply you can define as weight per unit volume. So due to time issues I am just trying to get faster and faster, so you can just rewind the video, so don't bother about it. Gamma is equal to weight upon volume, moist unit weight. So this moist unit weight you can define as gamma m. You can also write it as gamma bulk. Okay, so both of these are same. Other words you define gamma solids. One is you define gamma dry, one is you define gamma saturated, and other you define gamma submerged. So I'm trying to explain all of these one by one. I will try to explain all of these. So look, what is this? I will just continue with this one. This is gamma. So basically what is gamma? Gamma is simply this one, weight upon volume. Now this weight upon volume is termed in some other words, like when you consider the field. In the field soil is moist, or you can say it as bulk quantity. So this is defined as bulk unit weight or moist unit weight. So it is pretty simple that this is weight of moist soil upon volume of the soil. So it is simple. Then solids, we have just termed that this three-phase system consists of solids. So you would just consider weight of solids upon volume of solids. This is simply unit weight of soil solids. Then gamma dry you would come to know about. Gamma dry means you would just reduce the degree of saturation to 0% and then find out the unit weight. So it is of weight of dry soil divided by volume of soil. So you would define weight of dry soils upon volume of soils. Now the most important concept of saturated and submerged. You consider this one. You just try to fill up the voids. So when you try to fill up the voids with water, then degree of saturation will go on increasing. When this degree of saturation have any value between 0 to 100% but not equal to 100%. not equal to 100%, not equal to 0%. So on the basis of degree of saturation, When degree of saturation is 0%, we term it as dry soil. So in that case, gamma would be defined as dry density. When degree of saturation is exactly 100%, then you define as soil is fully saturated. In that case, you define as gamma saturated. And in between is the gamma bulk or gamma moist simply. In between. So wherever degree of saturation is in between 0 and 100%, but not 0 and not 100%, you define these two terms, gamma bulk and gamma moist. Okay, next I would just try to explain that whenever I would dip the soil, whole of the soil mass in water, then water will enter in this voids. So this water will enter, and when the volume of water exactly equals the volume of voids, for this degree of saturation is 100%. In this case, the unit weight is defined as saturated unit weight. Okay, so this saturated unit weight is simply for saturated weight upon volume of soil. But you can have a look that whenever I dip this soil in water, then there is displacement of particles. Now this water would consider this soil mass. Now these I just consider about solids. So these solids are just going to replace some amount of water. Say they are going to replace some W amount of water. This is some volume V. So I would just define displaced volume. So whenever some amount of volume is displaced, then this would result in an upward force or upward thrust on the dipped body. So that would be upward forced, and which would be equal to the weight of volume displaced. So whatever volume of water you displace, that much amount of, or the amount of force acting on this body is equal to the buoyant force, or that buoyant force Fb is equal to the weight of volume of water displaced. This is simply called as Archimedes principle. So I'm just trying to explain you that whenever you just submerge a soil, then due to effect of submergence, there is simply weight. This is saturated weight of soil, and some amount of weight of water would just get decreased, because this weight of water will act in upward direction as a buoyant force. So you will get a apparent weight which is termed as submerged unit weight. Is this okay with you? I would not hear any sound. Okay, let it be. This is W saturated. So this is the saturated weight of the soil. Now some amount of upward lift is acting, which is simply WW. So due to this, the net would be submerged weight of soil. This is the apparent weight. So whenever you divide by volume V, volume of this, so this much amount of volume of water, this much amount of saturated volume of soil, and this much amount of the submerged soil. So this is defined as gamma submerged, this is defined as gamma saturated, and this is defined as gamma W. This is, you get the important relation of gamma submerged and gamma saturated. So these are basically unit weights. This is when submerged case, hence you can define is or call it as buoyant unit weight. This is buoyant unit weight, and the concept of buoyant unit weight is based upon Archimedes principle. Okay, so this was just about